Welcome to Biology Made Easy. In today's lesson, we are comparing oxidative phosphorylation and photophosphorylation. Welcome. Let's have a very quick look through oxidative phosphorylation process, a quick look through photophosphorylation, and then the comparison we have put together in a table here. Well, oxidative phosphorylation taking place in the inner membrane of the mitochondrion, which is drawn here. The process is through the electron transport system, and you have chemiosmosis also. So we have oxidative phosphorylation. The process is powered by oxidation of food, glucose. In the process of oxidizing glucose, NAD reduced and fat reduced are produced that go through the electron carrier system, and NAD reduced will have hydrogen ions produce, electrons given off, goes through the electron carrier system. Fat reduced is oxidized, releases electrons and hydrogen ions. The electrons go through the electron carrier system. The hydrogen ions in both NAD reduced are pushed into the intermembrane space. The hydrogen ions from the fat is pushed into the intermembrane space, and the hydrogen ions are pulled and to high concentration and go through the ATP synthase, that's chemiosmosis. The hydrogen ions are removed. In the process, ATPs are formed. Now, as the electrons go through the electron carrier system, ATPs are produced along the line. The electrons lose energy, and the low-powered electrons combine with oxygen from cytochrome oxidase and hydrogen ions in the matrix to form water. This process we have discussed in a lesson on oxidative phosphorylation already, the detailed process. Now, photophosphorylation takes place in the chloroplast and specifically in the membranes of the thylakoid. So I have drawn one thylakoid here. This is a thylakoid membrane, another thylakoid membrane, and this area is the interthylakoid space or the thylakoid compartment. So here we have the thylakoid membrane, another thylakoid membrane. This is the thylakoid compartment here, and in photophosphorylation, the energy that powers the process is from sunlight. So sunlight energy hits photosystems 1 and photosystems 2. We discussed this in the light-dependent reaction, right? So we have here sunlight energy hitting photosystem 2. As the sunlight hits the photosystem, water is broken down, that is photolysis, and the hydrogen ions are pushed into the interthylakoid space. The electrons are carried through into photosystem 1 because sunlight energy hits photosystem 1 and the electrons in the chlorophyll are excited, so the electrons are released and go through the electron transport system. That is the ETS, is the electron transport system. Goes through the electron transport system, and the low-powered electrons combine with NADP plus hydrogen ions to form reduced NAD phosphates here. Well, the hydrogen ions from the photolysis plus hydrogen ions that are pushed from the stroma into the membrane and finally into the intermembrane space. So in photosynthesis, hydrogen ions do not only move from the membrane into the intermembrane space, but hydrogen ions are also shunted, pushed from the stroma into the thylakoid membrane and gets into the intermembrane space. So hydrogen ions are pushed into the membrane. They are pushed into the intermembrane space. They are pulled, and high concentrations here pushes the hydrogen ions through the ATP synthase, and it gets back into the stroma. The electrons from the photosystem 2, from the photolysis of water, move and get into photosystem 1. because photosystem 1 electrons also move from the chlorophyll into the electron carrier system. So electrons from the photosystem 2 go to replace the electrons that were lost in photosystem 1. Here, the low-powered electrons are finally combined with NAD phosphate and hydrogen ions to form reduced NAD phosphate. So these processes, the oxidative phosphorylation and photophosphorylation, there are similarities in the two and there are differences. So this day we are comparing the two. Oxidative phosphorylation is here, photophosphorylation is here. Remember, the ETS is the electron transport system. Good. Now, the process of this is powered by oxidation of food. You see, food is broken down, NAD reduced and fat reduced are formed. So the process is powered by oxidation of food, while here the process is powered by sunlight energy. Sunlight hitting the photosystems. Here, the process involves electron transports and chemiosmosis. Here, the same thing happens here. Process involves electron transports and chemiosmosis. Well, the process occurs on the inner membrane of the mitochondrium. This is the outer membrane. This is the inner membrane of the mitochondrium. The process occurs in there. And the same thing, the process occurred in the thylakoid membrane of the chloroplast membranes. Then the electrons that fed the electron transport system, that is the ETS, are from NAD reduced and fat reduced. That's this here. In photophosphorylation, the electrons that feed the electron transport system are from chlorophyll. They are from photosystems 1 and 2. Now, hydrogen ions that feed the system in oxidative phosphorylation are from NAD reduced and fat reduced. You see, the hydrogen ions from NAD reduced are pushed here, fat reduced are pushed. Then the hydrogen ions that feed the system in photophosphorylation, the hydrogen ions that feed the system are from photolysis of water. Here, photolysis of water, that's the hydrogen ions fit here. And also from the stroma. Hydrogen ions are pushed from the stroma, shunted across the membranes and into the interthylakoid space. Alright, so here, look at these two differences here. Then, low-powered electrons from the electron transport system are absorbed to form, after electrons have gone through the electron carrier system, ATPs forming along the line, the electrons becomes low-powered. And in oxidative phosphorylation, the low-powered electrons combine with oxygen and hydrogen ions to form water. That's it here. In photophosphorylation, the low-powered electrons, after they've gone through the electron carrier system, they lose energy. That is non-cyclic phosphorylation. The electrons combine with NAD phosphate and hydrogen ions to form NAD phosphate reduced. The outcome of the process, you have oxidative phosphorylation, you have ATPs formed. The ATPs are formed along the line. As the electrons move, ATPs are formed and water is also formed. NAD reduced becomes NAD, fat reduced becomes fat. So you have ATPs formed, water formed, NAD formed, fat formed. This is the outcome of oxidative phosphorylation. The outcome of photophosphorylation, you have ATPs formed. ATPs are formed along the electron transport system. ATPs are formed. So you have ATP, you have oxygen here giving off, that is oxygen, and then you have reduced NAD phosphate formed. One can also say that in comparing oxidative phosphorylation and photophosphorylation, even though we have photosystem 1 and 2 here, we can also say that in photophosphorylation, it involves photosystems 1 and 2, whereas here, there's no photosystem. Well, this brings us to the end of our comparison. If the lesson has been useful, please give us your thumb and kindly subscribe. Thank you very much. Goodbye.